This video explains the goal programming test that was given in the assignment. It is about taxation planning. We have Fairvill, which is a small city somewhere in America. They have given some annual taxation basis for real estate property, for instance, or for foods and drugs, general sales, and so forth. And now they want to develop the tax rate based on 4 main goals that they pursue. And we need to apply goal programming to help them to find out the tax rates. So first they require in goal 1 that the tax revenues must be at least $16 million to meet the city's financial commitments. That means that all the different tax bases that we have need to be in sum at least $16 million. That means that we have, by the way, we have given also some variables. In some variables, we have XP that presents the property. Property taxes. Then we have XF for food and drugs. We have given XS for general sales and XG, which is tax for gasoline. So we work with these variables, and now we have given the overall tax revenue goal. That is that the $550 million is the overall property tax. So we include now all taxes together to exceed or to be at least the 16 million. So it's 550 XP, 35 XF for food and drugs, plus 55 XS for general sales. And then we have 0.075 for the gasoline. And these need to exceed together $16 million. That looks already good as a constraint. Now we go to the second goal. And we have now that food and drug taxes cannot exceed 10% of all taxes collected. That means that now we take the 35 million for taxes for food and drugs, and these shall not exceed 10% of all taxes collected, and that means that we need to take the overall tax bases in sum and multiply it by the 10%. And now you see that the forms of the formulas are not the same. So in order to make it a little bit more simple for us to put it into Excel, for instance, we reformulate the constraint using some algebra. So first we want to reformulate the constraints so that we can have an easier way of putting it into Excel. And we multiply now, we want to lose the brackets first of all, and we multiply now every term with 0.1 in the brackets. So this becomes 55 XP plus 3.5 XF plus 5.5 XS plus 0.0075xg. And now what we can see is that we have here larger equal to, and here we have a smaller equal to, so we want to rearrange the terms a little bit. And what we do first is that we flip sides. So this needs to be larger or equal to 35xf. And now the second thing, you realize that we have both these terms here, so we can subtract off both sides now the 35xf, and then this equation becomes 55xp minus 31.5xf, and the rest stays the same. And this overall should be larger or equal to 0. So now the third goal is that general sales taxes cannot exceed 20% of all taxes collected. That is basically the same as we have seen above. So the general sales was 55xs, and they shall not exceed 20% of overall taxes, so they should be smaller or equal to 0.2, and the overall tax basis and now we do exactly the same as for goal 2. So first we get rid of the brackets. That is an S. I know it's difficult to see or individuate from the G. So 0.2 multiplied by this term, this term, and then that term. And this is then 110 xp plus 7 xf plus 11 xs plus 0.0. What does this become? Sorry, 0.015xg. And as before, you realize we have two terms for xs, of course, and we rearrange the terms. So what we can do first is we subtract the 11xs, so the 55 becomes 45, and then we rearrange the terms, and then the equation becomes as follows. We have the 110 xp plus 7xf minus 44 xs plus 0.015 xg, and these shall be larger or equal to 0. Now the last goal, the fourth goal, is fairly easy. Gasoline tax cannot exceed 2 cents per gallon. That means that our xg shall be smaller or equal to 2. The last thing that we need to denote is, of course, that all variables are larger or equal to 0. So now we are ready. We have formulated the goals, and now we can define the goal programming LP. Implementation. Now we take Excel, and here I copied the ready-to-use goal programming LP already in our view, so that we don't need to reproduce it. Here it includes the derivational variables. You recall that these are the constraints as we have just developed. And yeah, now I'm going to show you how this is implemented. So we have XP, we need XF, these are our standard variables, XS and XG. And then for each and every goal we need S1 minus, S1 plus, and these pairs we need now for all our 4 goals. So I'm gonna make a first version of that. So we need this for goal 2, 3, and 4, and changing shortly the names. So now these are ready to go. Let's make it look nice. So we have 4 goals. That is from G1 to G4. We put them aside. So here we have a nice table. The rest what we need now is the left hand side. Then we need the right hand side. And I want to have also the right hand side plus the deviation. And I use the usual color scheme because this becomes a calculation. And this as well. Then I don't have to care for it. Yeah, let's add the names so we know what we are doing. So this is the general tax. Then this one is food and drugs. The other one is general sales. And this is for gasoline. Now we need our decision variables. That are the following. And we need now for the goals, the penalty weights. That are given for the deviations. Now the next thing we need the objective. And let's do these first. So the left-hand side is some product of the coefficients multiplied by the decision variables. So this was successful. And now we want the right-hand side plus our deviations. And unfortunately there's no shortcut to do this calculation here. First is a plus. Now you also see why using ample for real size problems can be beneficial, because you don't have to type so much. Okay, and now we need the objective, which is in our case, when we use the weights method, that the sum product of the decision variables and the penalty weights should be minimized. So it's sum product of the variables multiplied by the penalties. And this is all for building up the template for this, or the structure for this model. Now we type in the coefficients, and we can use it just with the model. And now we include, and this is now interesting, for the penalty, no, I follow up later. So for the minus we use plus, and for the plus we give a minus. And these pairs are equal for all goals. No. Yeah, let's finish typing first. Is that correct? Yeah. 110, 7, 11, minus 44, sorry, 0.015. And the gasoline is now a 1. And I didn't type the right hand side, so this was 2 cents, this was 16 million, and the other two are 0. Okay, so now we are set for these. Now the penalty weights that we want to include. We want to include, you remember they were all, despite the fourth goal, they were larger or equal to. That means that we want to penalize the negative ones. So exceeding is no problem, but underscoring is a problem. So we include those. And for the last one that was smaller or equal to, we want to penalize exceeding this goal. So actually, the penalty is on S4 plus. And we have equal weight, so we just use a 1. And that's for the setup. Now we use the problem solver to type in the problem. It has recognized our objective already. We have a minimization problem. These are the decision variables. And our restriction is that the left-hand side should be equal to the right-hand side. We use the decision variables to be non-negative and the simplex to solve the model. So we have a solution. I make it a little bit larger and better to see. So now we have tax rates given. We have one for, I make the job easier for typing. Because the City Council wants to know the tax rates, we can now state them. So we can say this in percentage, looks nicer. And maybe make this a little bit larger. And we use this for all of them. So our results are that so the rate for the last one was that the gallon gasoline should not exceed 2 cents. So this is not expressed in percentage, of course, but the general tax for the country or for the city should be 2.59% for general taxes. For food and drugs, 4.6, and for general sales, it should be 0. Yeah, we see for the general taxes that there is in fact a derivation from the requirement that this should be larger or equal to the right-hand side, and we see it here that for the general sales we are this is a minus, so we are not reaching the goal. That means that 3.2 million, so the 3.2 million need to be added, which is expressed by the S3 plus. That means that the goal of just 20% for the overall tax of the general sales is not feasible. Okay, now we go to the task 2. Task 2, now we take the whiteboard again, and the task 2 states that we should add a goal that is we need to add the goal that requires gasoline tax to equal at least 20% of the total tax. So this is similar to what we have done before, but now we need to concentrate on the gasoline. So the goal for the gasoline taxes, that was 0.075 xg. This shall be now at least 20% of overall taxes, so larger or equal to 0.2 multiplied by our overall taxes. So this is replicating our tax rates, our tax basis to be precise, plus 55xs and plus 0.075 xg. And now we do the same. We use algebra to make the constraint more handy to include in the model. So first we use the brackets, and this then becomes 110 xp plus 7 xf plus 11 xs plus 0.015 xg. And the next thing is that we rearrange the terms, so I flip sides. 110 xp plus 7 xf plus 11 xs plus 0.015 xg, and this should be smaller or equal to 0.075 xg. And now we have xg twice on both sides, so I'm going to subtract from both sides. So I'm subtracting it from both sides, and then the constraint becomes the following. Minus 0.06 xg, smaller or equal to 0. Okay, now we can include this in Excel. We modify our model accordingly. We set in a new goal, G5, that we have just derived. Gasoline at least, I call it. And that was given by this constraint. So 110 plus 7. Now it is plus 11, and it was minus 0.06 for xg. And for the derivational variable now, it is a smaller or equal to. So, well, first we need to extend, of course, the model to include also these two for goal 5, the derivational variables. And we need to extend also to include the penalty weights and the decision variables accordingly. And we want to include also the right-hand side. And now the constraint was smaller or equal, so we actually don't, or we penalize exceeding this goal. We want to keep it smaller or equal, so we penalize the S5 plus. And we also need to extend our objective function accordingly. And then we need to modify the exit solver as well to regard the additional decision variables, and also the same for the constraints, where we want to change the one that we already have and extend it accordingly. Okay, so I don't say solve now because I want to add the right hand side. That should be 0. And we see that we have new tax rates given. The 3.05 now mean that, well, the requirement that at least 20% of the tax comes from gasolines cannot be fulfilled, together with the estimated consumption rate and the 2% per gasoline. With